Welcome to Math with John, Natural Number Arithmetic, Factoring. A very useful mathematical tool is factoring. This tool is used consistently throughout mathematics, including adding, subtracting, and multiplying fractions and simplifying square roots. The idea behind factoring is to start with a larger number and factor out numbers that divide evenly into it, with all the factors when multiplied together equaling the original number. Sometimes this is a multi-step process. First, factor 36 into 9 times 4, and then factor 9 and 4 into 3 squared times 2 squared. The numbers 3 and 2 cannot be further factored, since no numbers other than 1 and itself divides evenly into them. A number, such as 3 and 2, that cannot be factored into smaller numbers is called a prime number. Prime numbers. Prime numbers are positive integers, greater than or equal to 2, so not 1, that have only itself and 1 as positive numbers that evenly divide into it. What I just said and what is written in the video are slightly different, but have the same meaning. Pick the definition that is the most understandable for you. 1 is not a prime number by definition. The lowest prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Definitely memorize as many of these as you can. This will make problems easier to understand and easier to solve. There are an infinite number of prime numbers, which means that there is no prime number that is the largest prime. Prime factorization. Every natural number greater than or equal to 2 can be factored into its very own unique set of prime factors. For a prime number, this factorization is just itself. For example, 2 is equal to 2. 4 is equal to 2 squared. 6 is equal to 2 times 3. And 12 is equal to 2 squared times 3. Basically, this is what factorization is all about. There are a bunch of numbers that are prime numbers. Factoring involves figuring out which prime numbers dividing evenly into a number, and then for each prime number that divides evenly into it, figuring out the biggest power of that prime that still divides evenly into the number. Logistical details. The logistical details are what has to be done in order to successfully factor a number. The first step is to find some set of factors, not necessarily prime, such that when you multiply these factors together, you get your number. The next step is determine if all of your factors are prime. If not, then further factor any numbers that are not prime until all factors are prime numbers. Finally, for each prime number in the final factorization, combine all of the exponents so that the final answer is a product of prime numbers to some power. For example, 12 is equal to 4 times 3 is step 1. 4 is not prime. So step 2 is 4 is equal to 2 times 2, being careful to include the rest of the factors, the 3 in this case. And the final step is the prime factorization of combining the primes into powers of primes. 2 times 2 is equal to 2 squared, and 3 is 3 to the 1, or just, well, 3. So 12 indeed equals 2 squared times 3. And to factor 96, a more complicated problem, we get step 1 is to factor 96 into 48 and 2. And then 48 into 12 times 4 times 2. And then factor 12 into 4 times 3, keeping the rest of the factors correct. Step 4 is to factor the two 4s into 2 squared. The final last step is to combine all the 2's into one factor and the 3 into the other. There are 5 factors of 2, so the final answer is 2 to the 5th times 3. Keeping track of the correct exponent of 2 is non-trivial. Shortcuts for various primes. 2 divides into a number if that number ends in 2, 4, 6, 8, or 0. 4 divides into a number if it successfully divides into the last 2 digits of the number. This is only helpful for numbers with 3 or more digits, those greater than 100. 52 is divisible by 4 since 13 times 4 is equal to 52. So 352, 1252, and the third number on the screen are also divisible by 4. For 3 and 9, sum up the digits of the number. If this sum is divisible by 3, then the number is divisible by 3. For example, 51, since 5 plus 1 equal to 6, which is divisible by 3, is divisible by 3. If this sum is divisible by 9, then the number is divisible by 9. For example, 198, since 1 plus 9 plus 8 is equal to 18, is divisible by 9. 5 and 10 are well known. Numbers that end in 5 are divisible by 5, and numbers that end in 10 are divisible by 10 as well. Sample problems and comments. Equation 1 is 8 is equal to 2 cubed. Equation 2 is 56 is equal to 8 times 7, and as equation 1 shows, 8 is equal to 2 cubed. So 56 factors into 2 cubed times 7. Equation 3 is one way to factor 144 into 2 to the 4th times 3 squared. The approach here emphasizes exponent rules, as 144 is equal to 12 squared, which equals to 4 times 3 squared, which equals 4 squared times 3 squared. 4 is equal to 2 squared is the next step. 2 squared squared equals to 2 to the 2 times 2, and 2 times 2 is 4. So this gets us to 2 to the 4th times 3 squared, which is a final prime factorization. Equation 4 is dividing 2 into 94 to get 47. 47 is a prime number. Equation 5 needs to be memorized. 121 is equal to 11 squared. 11 is a prime. Equation 6 is simple. 19 equals to 19. 19 is a prime number, so this is factored as much as it can be. Equation 7 is factoring 27 equals to 9 times 3, then 3 into 9 into 3 squared, and then combining the powers of 3 into 3 cubed. Equation 8 builds on equation 7 after 54 is factored into 2 times 27. 27 is equal to 3 cubed, so 54 is equal to 2 times 3 cubed. Equation 9 is factoring 72 into the standard 9 times 8, which conveniently factors in one step to 3 squared times 2 cubed. Note that it is okay that the 3's are written before the 2's. Equation 10 requires dividing 76 by 2 to successfully get 38, and then 38 by 2 to get to 19. Then the 2's are combined to get 2 squared equals to 19. Thank you for watching this video. Please like and subscribe.